Hi there, this is Haddad here again. In this lecture, we are going to do our first lab to configure OSPF on this single area, or what we call it the backbone area. Let me directly show you what we have to do here. This is the graph that we have. This is our scenario. As you can see here, we have three routers, router 1 and router 2 and router 3. Router 1 is connected to router 2, router 2 is connected to router 3, okay? So these are the three routers that we have. These here are the interfaces that are on each of the routers. What we need to do, we need to make first to put the IP addresses as you can see here, and we have to create a bridge. So we go step by step on the configuration. And at the end, we are going to enable OSPF on all the routers, router 1, router 2, and router 3, inside the backbone area. You can see here area 0.0.0.0, which is area 0. That's the backbone area. And at the end, we need to find out if router 1 will be able, from the OSPF routing protocol, to reach the network, which is 3.3.3.0/24. Okay, so this is really what we need to do in this lab. So let's go directly and see what are the steps that we need to follow. So here are the steps that we need to follow. This is our first lab, and it's to configure OSPF on a single area. As you can see, we have 10 points to follow. We will do point by point. But before I start by point number 1, I just want to show you how I have configured my GNS3 here. So as you can see here, I have created here a cloud, and this cloud is really my own PC, the PC that I'm working on it now. And inside this cloud, I have created my GNS3 interface. That's really a Microsoft loopback interface. I named it GNS3 just to know or to recognize it that it is for GNS3. And I put on side of it an IP address. And then from this interface, the loopback interface, I have put the same range of IP address on this router, which is router 1 or MikroTik 1. And in this case, I have connectivity to MikroTik 1. Then I can open my Winbox. I can do Winbox to MikroTik 1 and then to MikroTik 2 and then to MikroTik 3 using the ROM. Okay, so this is really a very basic map that I have created on GNS3. This is the very basic scenario, as you can see. And it gives me really what I wanted to do in this lab, which is this picture. Okay, so let's see what we have to do in point number 1. Configure IP addresses on the router as on the picture. This is the picture that we are going to do for this lab. To make it easy, I will put it here also over my head. That means that whenever I move now, it's always on the top right of the window. Then you can see what are the IP addresses and how we are doing the configuration. It will be very easy for you to be able to follow the lab. Okay, so I go first to, we need to, on router 1, we have to create a loopback interface here. And we put an IP address on it 1.1.1.1/24. And on Ethernet 1, we have to put the IP address 192.168.12.1/24. Okay, let's just go directly to router number 1. That is my router 1. You can see here router 1. First, let me create the bridge interface. We can do it either by going to interface here and then we make plus and I create the bridge. Okay, or we can do it by going to bridge and from here I can go to bridge and then I can do plus. Okay, so let's do it from here. This interface is created. This bridge interface, I'm creating it to be like the loopback of 1.1.1.1. Okay, so you can consider it as an active interface, active virtual interface on our MikroTik router. And this is needed because we are saying that 1.1.1.0/24 is a network connected to router 1, just to be able to ping from router 1 to router 3, 3.3.3.3, or vice versa also. Okay. So the bridge interface has been created. Then I have to go to IP addresses. And then from here, I have to go and to new address and I put 1.1.1.1/24. And this IP address needs to be on bridge 1. Okay. That is the first IP I need to put. And the second IP is to put it on Ethernet 1 with an address of 192.168.12.1/24, and it's going to be on Ethernet 1. Okay, that's what we need to do on router 1. Now we go to router 2. This is router 2. We have to create an IP address on the Ethernet interface 1 with an IP 192.168.12.2 /24 on Ethernet interface 1. And then we have to create an IP 192.168.23.2/24 on the Ethernet interface 2. And then we have to go to router 3. Also, we have a bridge interface. This time I will go from interface here and then to a bridge. I create it. And then I call this. I go to IP address 3.3.3.3/24. This IP address has to go to the bridge 1 interface that we have just created. And then 192.168.23.3/24 has to go to the Ethernet interface 3. Okay. So the first point has been done. Okay. Now point number 2, we need to ping between adjacency routers to see if we have a reply. Okay, that means that router 1 needs to ping to router 2, router 2 needs to ping to router 3 to the connected interfaces. I go to router 1. So we go to a new terminal, and from here I will say ping 192.168.168.12.2. That's the IP address of Ethernet 1 on router 2, okay, which is the connected interface to router 1. And as you can see, I have a reply. Now I will go to router 2, to the terminal, and then I will say from router 2 to router 3, then it's ping 192.168.23.3. That's the IP address of Ethernet 3 on router 3. And I have a reply. That means router 1 can ping router 2, router 2 can ping router 3. Okay, so step number 2, also it is done. Do we have a reply? Yes, we do have a reply. Step number 3, ping from router 1 to 3.3.3.3. Do you have a reply? We go to router 1, that is router 1, and I will ping 3.3.3.3. So I'm pinging from router 1, if I open again the picture, from router 1 I'm trying to ping to this network here. Okay, to this network. And we don't have a reply. It says that no route to host, because we don't have any routing protocol enabled to be able for the ping packet to go from router 1 to the network of router 3, which is 3.3.3.0 or 3.3.3.3, the IP address, and come back to router 1. Okay, so we don't have a ping. Step number 3 is done. Now from now on, we have to start configuring OSPF. So what I have done now, I just created the IP addresses on the interfaces which are connected to each other, because OSPF, without having a connectivity between routers, if you enable it, it will not work. You need to have first connectivity, so you need to put the IP address and check if the connectivity between the connected router is working by using ping, for example. Now, step number 4, enable OSPF on router 1 and assign it a router ID 1.1.1.1, then advertise all connected interface to OSPF. So we have here to do 3 things. We have to enable OSPF on router 1, we have to put router ID 1.1.1.1 on router 1, and then we need to advertise all connected interfaces to the OSPF process. Okay, what is the router ID? When you enable the OSPF, there will be a process, we call it OSPF process. And then when routers needs to communicate to each other, the router which is enabled on OSPF will have like an ID, okay? And that will be the ID inside the OSPF process. Okay, so the router ID is really like the name of the router inside the OSPF process. We can set it manually, but also we can not set it manually. We will see it now when we do the lab. So let's go directly and start making the configuration on router 1 as they have asked us. Here I go to routing, and then from routing I have to go to OSPF. This is all the configuration to be done on OSPF will be from here. You can see all these things that we are going to pass through, most of them. Okay, so from here the configuration of OSPF will happen on the MikroTik routers. So first of all, I have to go to instances over here, and then I say plus. And from here we have the name of the instance and the router ID. Okay, they ask us to put the router ID 1.1.1.1. That is really the ID of the router inside the OSPF process again. So that's first thing to do. I have put the router ID. Then the second question is to enable OSPF and advertise all connected interfaces. So we are now in the process of enabling the OSPF. We have just put the router ID, and now we have to advertise all connected interfaces. So if I go here back to this picture, we can see here that router 1 has connected interfaces, which are a loopback interface. There is one connected interface, and Ethernet 1 is a connected interface. So what we need to do, we need to advertise those networks, which is 1.1.1.0 and 192.168.1.2.0. So what we have to do, we have to go to router 1 again. And from here, I will go to network, and I will say plus. I want to advertise 1.1.1.0/24. That's the network of the bridge 1 or loopback 0 that we have created. And the other thing I need to do is to advertise 192.168.1.2.0/24 inside the area, the backbone area. Okay, so all our configuration is going to happen inside the backbone area. And then I say okay. So these are the steps that I need to do to configure OSPF on router 1. Step number 5. Enable OSPF on router 2 and do not assign it a router ID. So we don't have to assign a router ID. Then advertise all connected interfaces to OSPF. It's the same steps that we have done on router 1, but the only difference is that the router ID, we don't want to put it manually. It will come automatically from the MikroTik router itself. The MikroTik router will look for an active interface which has the lowest IP address, and then it will choose it to be the router ID. Okay, so let's go and do it directly. So we go to routing, OSPF, and here we don't need to go to instances like we've done in the previous point for router 1, because we don't want to put a router ID here. Okay, so we keep it cancel, and then what I need to do is only to advertise the connected network to the router 2, which is in this case 192.168.1.2.0/24 on the backbone area, and 192.168.23.0/24 on the backbone area. Now we have two routers that are having OSPF enabled together, router 1 and router 2. I just checked now directly for the neighbors. I've seen that the router 2 has directly formed a neighbor with router 1. You can see this is the router ID of the router 1. It has formed a neighborship with them because router 1 and router 2, they're both having the OSPF enabled. Okay, and here we can see the LSA directly. They share the LSAs together, and from here we can see them. And you can see here the route. Now the router 2 know how to reach 1.1.1.0 network, okay, from the OSPF. All right, so this step is done. But before I go to the other step, let me go to router 1 now. There is router 1. And from here, I want to go to neighbors. You can see router 1 has formed neighbors with router 2, but the router ID of router 2 is what? Is 192.168.1.2.2. That's what the MikroTik router has chosen for MikroTik 2 or the router 2 to have as a router ID. And the reason behind that is because if you look here to the graph over here, we have advertised this and we have advertised this. Then the MikroTik looked which one has the lowest IP address. Is it 192.168.1.2.2 or 192.168.23.2, which are the IP addresses of those interfaces? And then he found out that this one is lower. And then in this case, he took that as the router ID. Okay, so this step is also done. Point number 5. Point number 6. Check if router 1 and router 2 have formed adjacency on OSPF. We have checked that. What router ID has received router 2 and why? We have also checked that already. Okay, so for now we have just configured router 1 and router 2. We have seen that they formed neighborship. We have talked about the router ID. We still have 3 points to follow. number 8, number 9, and number 10. I will stop the lab here and we will continue it in the upcoming lecture.